Picture this. You're on an adventurous hike navigating through lush forest and winding trails with your trusty GPS in hand. As you walk, you begin to wonder, how far have I actually traveled? If I wanted to head straight back to where I started, how would I figure out the shortest route? To answer these questions, we need to call on two fundamental concepts from physics, scalars and vectors. Let's take a quick moment to review. Scalars are the simple, straightforward quantities in physics. They tell you how much of something there is, its magnitude. For example, when you say, I walk 7 kilometers, or the temperature is 30 degrees, you're talking about scalars. They're just numbers, no strings attached. Vectors, on the other hand, are a little more exciting. They don't just stop at telling you how much, they also tell you which way. Imagine saying, I ran 10 meters per second to the north. Now we're dealing with a vector because it combines magnitude, 10 meters per second, and direction, north. With that foundation in mind, let's apply what we know to a classic physics scenario. The hiking scenario. You're on a hike and your GPS shows that you walked 3 kilometers north and then 4 kilometers east. Here are the questions to think about. 1. What is the total distance you've walked so far? 2. What is your displacement from your starting point, including its magnitude and direction? 3. If you decide to walk straight back to your starting point, what would your displacement vector look like? Let's break this down step by step. Question 1. What is the total distance you've walked so far? Here's a guiding question. What does distance mean? Is it concerned with direction or just the total ground covered? Remember, distance is a scalar quantity. It doesn't care about where you're going. It just adds up the total path you've taken. You've walked 3 kilometers north and then 4 kilometers east, since distance is simply the sum of the paths. Distance equals 3 kilometers plus 4 kilometers, which equals 7 kilometers. So your total distance is 7 kilometers. Easy enough, right? Question 2. What is your displacement from your starting point, including its magnitude and direction? Let's move on to displacement. Unlike distance, which just adds up how far you've traveled, displacement tells us the shortest straight line path between where you started and where you ended up. This means displacement is a vector. It has both magnitude, how far, and direction, which way. Step 1. Visualize the problem. Imagine this. You walk 3 kilometers north, then you walk 4 kilometers east. These two paths form the legs of a right triangle. The displacement we're looking for is the hypotenuse, the diagonal side of the triangle that connects your starting point to your ending point. Step 2. What is the Pythagorean theorem? The Pythagorean theorem states that in a right triangle, the square of the hypotenuse, the longest side, is equal to the sum of the squares of the two shorter sides, the legs. Mathematically, a squared plus b squared equals c squared, where a and b are the lengths of the legs, in this case, your north and east walks. C is the hypotenuse, your displacement. Step 3. Apply the Pythagorean theorem. Now plug in the numbers. You walk 3 kilometers north, a equals 3, and 4 kilometers east, b equals 4. Using the formula, c squared equals 3 squared plus 4 squared. C squared equals 9 plus 16. C squared equals 25. Now take the square root of both sides to find C. C equals the square root of 25, which equals 5. So your displacement magnitude is 5 kilometers. This means the straight line distance between where you started and where you are now is 5 kilometers. Step 4. Find the direction. Displacement is a vector, so we need to calculate the direction as well. Direction tells us which way the displacement is pointing, relative to a reference direction like north, south, east, or west. Here's where trigonometry comes in. To find the direction, we use the tangent function. The tangent of the angle equals the opposite side divided by the adjacent side. In our case, the opposite side is your northward walk, 3 kilometers. The adjacent side is your eastward walk, 4 kilometers. Now calculate the angle. Theta equals the inverse tangent of 3 divided by 4. Using a calculator, theta is approximately 36.87 degrees, so the direction of your displacement is 36.87 degrees north of east. Step 5. Write the final answer. Your displacement from your starting point is magnitude, 5 kilometers, direction, 36.87 degrees north of east. This means that if you were to draw a straight line from your starting point to where you are now, it would measure 5 kilometers and point slightly northeast. Question: medium level scalars and vectors. A boat is crossing a river that flows due east at 5 meters per second. The boat can move at a maximum speed of 10 meters per second relative to the water. What direction should the boat head to go directly north across the river? How long will it take the boat to cross the river if it is 200 meters wide? Engaging explanation with simplified steps. Let's picture the situation. Imagine standing on the shore of a river. The water is flowing to your right, east, at 5 meters per second. You're in a boat, and your goal is to row straight across to the opposite side of the river, directly north. But here's the problem. The river's current is trying to push you sideways, east. How can you make it straight across? Let's figure this out step by step. Part 1. Finding the direction. To go straight across north, you need to counteract the river's eastward push. This means you must aim your boat slightly upstream to the west of north so the current doesn't carry you away. Here's how we calculate the exact angle. Step 1. Break down the motion. Your boat's speed has two components. One part counters the river's current, east-west direction. The other part moves you directly north across the river. Think of these as forming a right triangle. The river's current, 5 meters per second, is one side of the triangle eastward. The boat's total speed, 10 meters per second, is the hypotenuse. The remaining side is your northward movement. To find the angle, which is how much you need to aim west of north, we use the sine function. Why? Because sine relates the opposite side, eastward current, to the hypotenuse, boat speed. The formula is sine of theta equals opposite divided by hypotenuse. Step 2. Plug in the numbers. The opposite side, river's current, is 5 meters per second and the hypotenuse, boat speed, is 10 meters per second. Sine of theta equals 5 divided by 10, which equals 0.5. Step 3. Solve for theta. To find the angle, we use the inverse sine function. Theta equals the inverse sine of 0.5. On a calculator, theta equals 30 degrees. Step 4. Interpret the answer. The boat needs to aim 30 degrees west of north to cancel out the river's current and go straight across. Part 2. Time to cross the river. Now that we know the direction, let's figure out how long it will take to cross the river. Step 1. Focus on the northward speed. Only the northward part of the boat's speed moves you across the river. To find this, we use the cosine function, which relates the adjacent side, northward speed, to the hypotenuse, total boat speed. The formula is cosine of theta equals adjacent divided by hypotenuse. Rearranging to find the northward speed. Northward speed equals boat speed multiplied by the cosine of theta. Step 2. Plug in the numbers. The boat speed is 10 meters per second and cosine of 30 degrees is approximately 0.866. Northward speed equals 10 multiplied by 0.866. Northward speed is approximately 8.66 meters per second. Step 3. Calculate the time. Time is distance divided by speed. The river is 200 meters wide, and the northward speed is 8.66 meters per second. Time equals distance divided by speed. Time equals 200 divided by 8.66. Time is approximately 23.1 seconds. Step 4. Interpret the answer. It will take the boat approximately 23.1 seconds to cross the river. Summary. The boat must aim 30 degrees west of north to counteract the river's current. It will take 23.1 seconds to cross the 200-meter wide river. Why this problem is fun. This question combines the beauty of vectors with real-world problem solving. It's like being a navigator steering a ship against the force of nature. And the best part? These skills aren't just for boats. They apply to airplanes flying in the wind, currents affecting swimmers, and even spacecraft navigating through space. Physics is everywhere.